Like previous videos, we should also learn in this video how heat is transferred, but in this case we learn the heat transfer of heat through roof. So how heat is transferred through roof, now we learn in this video. So similar to above, we use same formula. We use formula of Q is equal to UA CLTDC. CLTDC is corrected value of cooling load temperature difference. U is overall heat transfer coefficient, and A is area. So now the difference between two is that we use different chart for uh, here we find cooling load. This is chart 6 point table 6.1. So in this table we use is used for measuring of cooling load temperature difference. So here you see these are values of U, and these are all value of cooling load temperature difference with solar time. But this table is for if you with if you use with if you have roof without suspending ceiling, so then you use this chart. So if a roof is with suspended ceiling, then we use table 6.1, but we use this table. So this table having also U values with, and these are uh, solar time, and these are value of cooling load temperature difference. So this is next table. So this is table 6.4, and this table is used for measuring cooling load temperature difference, and we mainly use horizontal for this. So now here you see we have this example. So with the help of this example, we measure we can measure the heat transfer through wall. So we have a 30 foot by 40 foot roof of a building in Washington DC. Is constructed of 4-inch heavyweight concrete with 1-inch insulation and suspended ceiling. The inside temperature is 76 Fahrenheit. Find the roof cooling load at 2 p.m. solar time on July 21. So first of all, we measure the cooling load temperature difference. So uh, as you know that here there we have 4-inch heavyweight concrete insulation and a suspending ceiling. So we use, that's why we use this with suspended ceiling. So now the we see the 4-inch heavyweight concrete. So here you see this is a 4-inch heavyweight concrete, and solar time is 2 p.m. 2 p.m. is basically 14 o'clock. So now the value of cooling load temperature difference is 29. So at 2 p.m. we have cooling load temperature difference of 29 Fahrenheit. Now next we measure the value of Lm. So here you see we have June uh, June 20, July 21 is our peak, our time over, and we have the latitude of Washington DC is 40. So that's one why we measure this. And now here you see the Lm value is 1f. So we write here Lm value of 1f. Similarly, we can measure the value of Dr by using table A9. So and for Washington DC, uh, the outside temperature, peak outside temperature is 95, and Dr value is 18 Fahrenheit. So फिर 95 minus 18 by 2 is 86 Fahrenheit. So we get T naught value of 86 Fahrenheit, and the value of the U value, U factor for this 4-inch heavyweight concrete is 0.128. So we measure this value from here. So we write here U value to 0.128, area is 40 multiplied by 30, 1200 square feet, and CLTD value we get here, CLT value, DC value 33 Fahrenheit. So we multiply all these and we get my value of 5070 BTU per hour.